Clyde in Saskatoon, Canada. Ooh, I like saying that one. Saskatoon. He writes, he says, I often hear people say that a speaker was voiced to match an amplifier. I hear you use the same statement in a video the other day that your company used the Infinity system in room 2 to voice an amplifier. I'm not clear on exactly what that means. Me neither. I'd appreciate it if you could explain in the Paul way, simple with no bullshit, no BS, sorry, exactly what it means and how it might be accomplished. Sure, I know that we banter these terms about, and sometimes they're just, you know, hard to understand when we talk about voicing an amplifier. That seems kind of counterintuitive. So this is our test bench in engineering. It's one of them. There's the audio precision system that we rely heavily on. And the process we go through to design an amplifier starts at, you know, the scribbling. Well, I've got an idea how to do this and that. And we'll usually run it in a program called SPICE, which is a computer simulation of a circuit. So we can, without having to build a circuit, we can go into this LT SPICE and put, you know, a tube or a transistor or what, and we have models for all of these, and resistors and capacitors, and you design it literally on the screen, and then you put a signal into it, and it shows you what comes out. And you can measure the distortion, you can do all of that just as if you had built the circuit. That's sort of a modern day way, not the way I used to do it, which was to noodle it in my head, and then I would have what we call a proto board, and I would literally put the parts in on the proto board, put it up on that old version of the HP analyzers and things in my day, and tune the circuit and then make a prototype and blah, blah, blah. However it is done, whether it was my old way or today's new way with the LT SPICE program, and once we get that, then we make a prototype, and then we put it on the AP, and we get everything looking good. So all the things that we want. Distortion is where we want, step response, square wave response, everything that we look for, open loop bandwidth, how much, all that stuff, okay. Then we go to phase whatever, and that goes to the listening room. All these great ideas of the amplifier or the preamplifier that we had, how do they manifest themselves in the way that they sound? Because circuits don't sound the same, even if they have the same distortion, if the same gain products. Because if you take, let's say you take a certain kind of amplifier that has very high open loop gain, so high that if you didn't close the loop back down with feedback, it wouldn't even operate. And let's say that it's open loop, meaning no feedback, bandwidth is such that it only goes to a couple of hundred hertz or a couple thousand hertz. That circuit with the identical gain is going to sound different than one whose open loop response without feedback operates without that feedback. They're just going to sound different, okay? Even though they may measure the same. So then we go upstairs and we listen. We put on all of our favorite tracks. And this is where the voicing comes in. Here is where we listen, and we're listening for, let's say in certain areas I will listen, or Darren will listen, and we'll hear a guitar pluck. And the overtones of that guitar pluck could be anywhere from like, wow, just live and, you know, just like we had recorded it. Or it could be kind of stale and muted and with a quick diminish to where you don't really hear the ringing going on, you know, forever. So there's two differences that we might hear, just as an example, okay? So our goal, of course, is within the circuit's parameters, what can we do to change the voice, to change the way that sounds, because I want to hear those strings ringing, okay? So then we go back and we scratch our heads and say, all right, we know that, let's say, I'm just going to pick something out of the air here. Let's just say that it has limited bandwidth. Let's say that our basic amplifier maybe goes up to its 3 dB down point, where it starts to roll off is like 30K, well outside the range of human hearing. Well, with a 3 dB down point at 30K, we know that there's going to be phase shift and problems down into the audible range that we hear, and we likely would hear that in those openness or not openness of the strings. So to change the voice of the amplifier, we might say, let's extend the bandwidth out to, say, 60K and see what happens. So in this particular circuit, we do that, we go up, now there's ringing, okay? That's just an example. Don't get all jiggy and weirded out, because I know there are people watching this going, but that's what we do. And that's what voicing is. And maybe there's not enough chest in a singer's voice, and then there's things we can do for that. And maybe there's not enough depth, or the speakers don't disappear, or it sounds grainy or harsh or something. So we change the voice, the character of the sound coming out of the equipment. So there you have it. That's what voicing is all about. Thanks for the question. I'll talk to you later. Bye.